an upon bn is equals to infinity, right? An upon bn is equals to infinity. So by using the third result, that is, if we have limit is equals to infinity and bn as a convergent series, then summation an converges. Bn as a convergent series, then summation an converges, right? But by p-test, summation bn, that is summation 1 upon n, is the divergent series or is the diverges, and so by limit comparison test, summation an diverges. So these are examples for limit comparison test. Now let us see the next result in our presentation, that is a ratio test. Ratio test says that if we have a positive term series and the limit n tends to infinity n plus 1 upon n is equals to p, limit n tends to infinity n plus 1 upon n is equals to p, then according to the different values of p, we have some convergence and divergence series. If the value of p is less than 1, then the series will converge, and if the value of p is greater than 1, the series diverges, and if p is equals to 1, then test is inconclusive. That means by ratio test we cannot say that the given series is convergent or divergent, right? Now here n plus 1 upon n, the name of this test is ratio test, and that is because of n plus 1 upon n. N plus 1 upon n is nothing but a ratio of two consecutive terms of a series, right? Now in that term, by ratio test it says that p is less than 1. That means if the limit of ratio is less than 1, then the series converges, and if the ratio will greater than 1, then series is diverges, and if you have ratio is equals to 1, then series is inconclusive, the test is inconclusive. That means we cannot say about the convergenceness or divergenceness of that series. Now let us see some examples for that ratio test. Now in a ratio test, what we have as a first example, summation n is equals to 1 to infinity n factorial upon e raised to n, n factorial upon e raised to n, right? Now its solution is given by, here we have an is equals to n factorial upon e raised to n, n factorial upon e raised to n. Now from that term we can say that n plus is nothing but n plus 1 factorial upon e raised to n plus 1. That means we have to replace n by n plus 1 in an. Now to use the ratio test, we have to calculate limit n tends to infinity n plus 1 upon an, that is equals to limit n tends to infinity n plus 1 is nothing but n plus 1 factorial divided by e raised to n plus 1 multiplied divided by an. N is n factorial upon e raised to n, so it is of the form n factorial upon e raised to n. Denominator of denominator is numerator, therefore it will be e raised to n upon n factorial. Now that limit is equals to, we have limit n tends to infinity n plus 1 factorial. N plus 1 factorial will be n plus 1 into n factorial divided by e raised to n plus 1 is nothing but e raised to n into e, and the next term will be e raised to n upon n factorial. N factorial will be cancelled out, e raised to n will be cancelled out, and we have final result as a limit n tends to infinity n plus 1 upon e. When we take n tends to infinity, this n plus 1 will goes to infinity, and infinity upon some finite number is going to be infinity, which is greater than 1. So by ratio test, we have that limit n plus 1 upon n is greater than 1. Therefore, by ratio test, summation an diverges because that limit is greater than 1. Now second example is summation n is equals to 1 to infinity 10 raised to n upon n raised to 10. Here what we have as the an is 10 raised to n upon n raised to 10, and from that n plus 1 can be obtained by replacing n by n plus 1 in the terms of an. So we get 10 raised to n plus 1 and n plus 1 raised to 10. Now to apply the ratio test, let us calculate the limit n tends to infinity n plus 1 upon an is equals to limit n tends to infinity an plus 1 is nothing but 10 raised to n plus 1 upon n plus 1 raised to 10 into an. An is denominator, so the final term of that an will be n raised to 10 divided by 10 raised to n. Now this 10 raised to n plus 1 can be written as limit n tends to infinity 10 raised to n into 10 into n raised to 10. Now take n common from this n plus 1, and if we take n common from this n plus 1 outside of that bracket, the final term will be n raised to 10, and inner side what we have 1 plus 1 upon n raised to 10 into 10 raised to n. Now n raised to 10 n raised to 10 cancelled out, 10 raised to n 10 raised to n cancelled out, and we get that term is the final limit n tends to infinity 10 upon 1 plus 1 by n raised to n. Now if we take n tends to infinity, this 1 upon n will goes to 0. Therefore 1 plus 1 upon n raised to 10, right, and it will goes to 1. Therefore that final limit is equals to, we get 10. Again this is greater than 1, so by ratio test summation an diverges because that limit is greater than 1. Now let us take third example. Third example is that summation n is equals to 1 to infinity n ln n upon 2 raised to n ln n upon 2 raised to n, right. So here what we have as a an is n times ln n upon 2 raised to n. Now from that an plus 1 will be n plus 1 ln n plus 1 divided by 2 raised to n plus 1. Now let us calculate limit n tends to infinity n plus 1 upon an, that is equals to limit n tends to infinity n plus 1 upon an will be n plus 1 ln n plus 1 divided by 2 raised to n plus 1 multiplied with 2 raised to n divided by n times ln n, right. So that is equals to what we have, limit n tends to infinity 2 raised to n plus 1. Here we have n plus 1 is same as n times 1 plus 1 upon n. Now this ln n plus 1, for that what we do, here this n plus 1 can be written as n times 1 plus 1 upon n, right, into 2 raised to n is already there, divided by 2 raised to n plus 1 is nothing but 2 raised to n into 2 n times ln n. Now 2 raised to n cancelled out, n will be cancelled out. Now here we have ln n 1 plus 1 upon n, and that term will be ln n into ln 1 plus 1 upon n divided by 2 into ln n, because we know the result that if we have ln a into b, then it is nothing but ln a into ln b, right? So ln n will be cancelled out, and we get that is equals to limit n tends to infinity ln 1 plus 1 upon n divided by 2, right? So here we have limit n tends to infinity ln 1 plus 1 upon n by 2. Now if we take n tends to infinity, since ln is a continuous function, we can take limit inside, and 1 upon n will goes to 0, and we get ln 1. ln 1 is 0, and ultimately this limit is going to be 0. So limit n tends to infinity an plus 1 upon an is less than 1, right? That means that ratio is less than 1. So by ratio test, summation an is a convergent series, right? That series is a convergent series. Now let us take fourth example, that is summation n is equals to 1 to infinity n plus 3 factorial divided by 3 factorial n factorial 3 raised to n, right? Now here what we have as a an is n plus 3 factorial upon 3 factorial n factorial into 3 raised to n, and from that we have an plus 1 is equals to n plus 4 factorial divided by 3 factorial will be as it is because it's independent of n, then n factorial will convert it to n plus 1 factorial 3 raised to n plus 1, right? Now for a limit comparison, for ratio test, let us calculate limit n tends to infinity an plus 1 upon an is equals to limit n tends to infinity an plus 1. An plus 1 is nothing but n plus 4 factorial divided by 3 factorial n plus 1 factorial 3 raised to n plus 1 multiplied with 1 upon an. 1 upon an means the reciprocal of an is nothing but n plus 3 factorial n factorial 3 raised to n. Now at the initial stage 3 factorial will be cancelled out. Now this n plus 4 factorial, this n plus 4 factorial can be written as n plus 4 into n plus 3 factorial, right? So that term is going to be limit n tends to infinity n plus 4 into n plus 3 factorial into n factorial into 3 raised to n divided by n plus 1 factorial 3 raised to n plus 1 into, now 3 raised to n plus 1 is same as 3 raised to n into 3, right? Then n plus 3 factorial as it is. Now n plus 3 factorial cancelled out, 3 raised to n cancelled out, and n plus 1 factorial is nothing but n plus 1 into n factorial. So this n plus 1 factorial is nothing but n plus 1 upon n plus 1 into n factorial. Now n factorial is cancelled out. So ultimately what we get as a final limit n tends to infinity n plus 4 divided by n plus 1 into 3, right? So that is equals to limit n tends to infinity, take n common from numerator, that is from n plus 4, and we get 1 plus 4 by n, and take n common from n plus 1 and we get as a final term n times 1 plus 1 upon n into 3. This n will be cancelled out. Now by taking n tends to infinity, 4 upon n will goes to 0, 1 by n again will goes to 0. Ultimately this limit is nothing but 1 by 3 and this value is less than 1, right? So by ratio test, summation an converges because we get that limit less than 1. So these are the examples of ratio test. Now let us take the next result, which is root test. Now in the root test, what we have to do, root test says that if we have a positive term series summation an and if we calculate the limit n tends to infinity nth root of an, then if the limit is less than 1, then the series will converge. If the limit is greater than 1, the series will diverge, and for p is equals to 1, the series is inconclusive, right? The series is inconclusive means again we cannot say that by root test that series is converges or diverges. So here we have the same result as we have in ratio test. That means the conclusion is same for both ratio test and root test, but the limit is different. That is, in a ratio test we have limit n tends to infinity n plus 1 upon n, and here we have the limit n tends to infinity nth root of an is equals to n. Now let us take one example for that ratio test. The first example for that ratio test is summation n is equals to 1 to infinity ln n raised to n upon n raised to n. So here what we have, an is equals to ln n raised to n upon n raised to n, right? Now limit n tends to infinity nth root of an is nothing but limit n tends to infinity ln n upon n raised to n whole raised to 1 by n, because the nth root is nothing but power 1 by n. N will be cancelled out and we get the final limit as the limit n tends to infinity ln n upon n. Again we have infinity by infinity terms, and so by ratio test, L'Hopital rule, we get derivative of ln n is 1 upon n and derivative of n is 1, and this value is nothing but 0, which is less than 1. Therefore summation an converges